You live here on this planet, Earth, a small sphere floating in the vast expanse of the cosmos, and everything you've ever known, every experience, every person, every moment, has happened right here. But when you look beyond Earth, beyond the skies that envelop us, you begin to realize just how small and insignificant our planet is when compared to the colossal scale of the entire universe. To truly grasp the enormity of the universe, we must zoom out and start our journey by exploring our closest celestial neighbor, the Moon. The Moon has always been a symbol of mystery and fascination for humanity. It looms large in our night skies, appearing as though it's almost within reach. But in reality, the Moon is far from close. The average distance between the Earth and the Moon is a staggering 384,400 kilometers. To put that distance into perspective, you could fit 30 entire Earths in the space between our planet and the Moon. If you somehow managed to drive a car at a constant speed of 100 kilometers per hour, it would take you approximately 160 days, without any breaks, just to cover the distance between Earth and the Moon. Yet, despite this immense distance, humans have accomplished the impossible. 12 astronauts have set foot on the lunar surface, a feat that represents one of the most significant achievements in human history. From the Moon, Earth appears as a small, distant blue dot, a striking reminder of just how far those astronauts had traveled from their home. While they stood on the lunar surface, any attempt to communicate with loved ones back on Earth would have taken about 2.5 seconds for a message to travel, because that's how fast light and radio signals travel through the vacuum of space. But let's venture farther than the Moon, beyond the realm of our nightly companion, to another world, Mars. The red planet is, on average, 225 million kilometers away from Earth. That distance is so great that it can expand to as much as 401 million kilometers depending on the orbits of both planets. To put this distance into even more mind-boggling terms, when humanity eventually sets foot on Mars, those astronauts will be 986 times farther from Earth than the astronauts who landed on the Moon were. Communication between Mars and Earth would become much more challenging, too. Instead of a 2.5-second delay, messages would take approximately 20 minutes to travel between Mars and Earth, making real-time communication impossible. In an emergency, astronauts would be isolated by both distance and time, relying solely on their training and resources. But our journey doesn't end at Mars. Farther still, we encounter Voyager 1, the farthest human-made object from Earth. Launched in 1977, Voyager 1 has been traveling for decades and is currently 138 astronomical units, AU, from Earth. 1 astronomical unit is the distance between the Earth and the Sun, roughly 150 million kilometers, so Voyager 1 is 138 times farther from us than the Sun is. At this unfathomable distance, Voyager 1 sent back one of the most remarkable images in history, the famous pale blue dot photograph. It shows Earth as a tiny speck, suspended in a sunbeam, almost invisible against the vastness of space. Carl Sagan's reflection on this image is one of the most profound expressions of humanity's place in the universe. He said, "If you look at it, you see a dot. That's here. That's home. That's us. On it, everyone you ever heard of, every human being who ever lived out their lives. The aggregate of all our joys and sufferings, thousands of confident religions, ideologies, and economic doctrines. Every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam." This powerful message underscores just how small and fragile our existence is in the grand scheme of the universe. And even though Voyager 1 is traveling at a speed of 17 kilometers per second, it will take another 30,000 years for it to exit our solar system. Beyond our solar system, we enter a region known as our interstellar neighborhood, where distances become so enormous that we measure them in light years, the distance that light travels in 1 year, which is roughly 9.461 trillion kilometers. The closest star to our Sun, Proxima Centauri, is 4.24 light-years away. Even if Voyager 1 were heading toward it, the spacecraft would need over 70,000 years to reach the star. To put this in perspective, imagine driving your car at 100 kilometers per hour, as in our earlier example of reaching the Moon. To drive to Proxima Centauri would take over 6 times longer than the entire age of the universe itself, around 93 billion years. These astronomical distances truly boggle the mind, making us realize how limited our current technology is in reaching the stars. Zooming out even further, we come to our entire galaxy, the Milky Way. Our solar system is located in one of its spiral arms, and the galaxy stretches over 100,000 light-years from one end to the other. The Milky Way contains over 100 billion stars and possibly as many planets. However, when you look up at the night sky, you're only seeing a tiny fraction of the stars within our galaxy, confined to a small region that's visible to the naked eye. But even the Milky Way is just a small part of something much larger. Our galaxy belongs to a collection of galaxies known as the Local Group, which contains 54 galaxies and spans 10 million light-years. Yet this too is part of an even greater structure, the Virgo supercluster, a collection of galaxy groups that stretches across 110 million light-years. Within this supercluster, there are at least 100 other groups of galaxies just like our own local group. The Virgo supercluster, however, is just a fragment of a colossal structure known as the Laniakea supercluster. This vast cosmic web spans 520 million light-years and contains over 100,000 galaxies. Even at this scale, we're still only scratching the surface of the universe. When we zoom out to the fullest extent of what we can observe, we arrive at the edge of the observable universe. This is a sphere around us with a radius of 46.5 billion light-years, containing everything that we can currently see or detect. Inside this observable universe are at least 2 trillion galaxies, each filled with stars, planets, and potentially life. The sheer number of stars is greater than all the grains of sand on Earth, and the entire width of the observable universe stretches 93 billion light-years across. But the observable universe is just that, observable. There is every reason to believe that beyond what we can see, the universe extends even farther, perhaps infinitely. Some regions are so far away that their light hasn't had enough time to reach us yet. And some parts of space are expanding faster than the speed of light, meaning that their light may never reach us. These distant regions are beyond our grasp, locked away in the ever-expanding fabric of space-time. According to the theory of cosmic inflation, proposed by Dr. Alan Guth, the universe could be vastly larger than the observable universe. If the inflationary model is correct, the entire universe could be 150 sextillion times larger than what we can currently observe. That number looks like this, 150 sextillion. This is a number so large it's almost impossible to comprehend. Imagine the observable universe, the part we can see, as the size of a light bulb. Now imagine that the entire universe is the size of Pluto. We, inside our tiny light bulb, are completely unaware of the immense reality that lies beyond. This analogy is still an understatement of how vast the actual universe may be. In the grand scheme of things, we are small, unbelievably small. But that shouldn't discourage us. Instead, it should inspire us. Here at Waves Discovery, we believe that the universe's vastness is a testament to how much more there is to learn, explore, and understand. Humanity may be just a speck in the cosmos, but we have the curiosity and drive to push the boundaries of what we know. Together, we are explorers of the infinite, and there is still so much left out there for us to discover.